So we want to welcome Jessica Brewer, Computer Science Outreach Coordinator at Purdue University, as she's going to talk to you guys about coding with Block. And so we're going to turn it over to her and we'll get started.
All right. Hello, everyone. Real quick, if you could, I know Kathleen already did in the chat, if you could just let me know what grades you teach, and if you're just a general science teacher, if you actually specialize in computer science teaching, and then if you have any coding experience, especially in Scratch. Perfect. So as Bill said, I'm Jessica Brewer. I am the new Computer Science Outreach Coordinator here at Purdue. It has been an adventure leaving the classroom, that's for sure, but it's kind of fun to be in this role to help you guys in the trenches instead of being in the trenches. So a little history about me. I graduated from Purdue. My original background is in geology and natural resources. Then I went and got my master's degree in GIS and remote sensing, which is kind of where my computer science background comes in from. And then from there, I worked in precision ag for a few years. I've worked in Canada and Argentina doing uranium exploration. And then I was in the classroom for a few years, for 7 years. And then now I'm here. So welcome, everybody. This is my first presentation of giving a professional development. So hopefully you'll bear with me. I might say ums and uhs a lot. And then fidget, stand up, sit down. You know how it is sometimes middle school kids. I'm pretty much the same. So awesome. Thank you, Chris. Perfect. Okay, so it looks like not everybody has a lot of coding experience, which is great. Welcome. You are in the right place for sure. The professional development I'm going to give in a few weeks is more advanced. It's actually in Python coding. So if you find today too simple, please come back in a few weeks, or come back in a few weeks just to see, you know, a different programming language. That would be awesome too. Hopefully you guys can see my screen fine. This is the actual unit plan. I put together a 5-day lesson unit plan that goes along with your physical science standards. So that way, since most of you are general science, you're able to incorporate this coding at the end of your like Newton's laws units. So.
And we shared that link in the chat. So that's the first link we shared. The second link, Jessica will talk about here in a couple minutes, but we wanted to make sure that you knew where this is coming from.
Yeah. So the first link is what I'm gonna start with real quick. As you can see, it's to go along with our Exploring the Universe theme this summer. I went ahead and decided to do a lunar landing game because it is kind of fun. Plus, I know sixth grade science uses a lot of the space standards, so that'll be, you can use it in 6th grade, but also then as they progress through 7th and 8th grade, you know, all the physical science standards as well. And then eventually we'll get into using the GoDirect force and acceleration sensor, if you have those in your classroom as well, how to incorporate that into the Scratch coding. So, okay, so just a quick overview as we go down through the lesson plan here. Like I said, it is a 5-day. Obviously, you guys are teachers, you understand, especially in middle school, that kids either work faster than what you plan or much slower than you plan. And so, you know, this is just a general idea of how to, it's more like a scaffolding approach to, you know, starting small and then working your way big. And then it's up to you how much time you want to give to your students, like actual class time and how long it'll work. So, obviously, administration loves objectives, so I have the objectives in there for you. So basically, you're going to be working on your physical science concepts and then putting that into different coding skills, because I know that some of you have to teach coding standards along with your regular standards. So these kind of like help incorporate both, or you can use it as an enrichment, like when you're done, like, okay, we're going to take a break from the standards this week and let's go do a fun activity in computer science. So some of the materials you're going to need, you will need internet access. Unfortunately, the sensor does not work with the Scratch link and iPads. So if you are at iPad school, you can still do all the coding stuff. You just won't be able to use the sensor as part of the coding, which I'll explain all that in a little bit. Some helpful links. So this first link here, maybe,
It should come on your computer.
yeah.
Did it open in a new tab?
Oh.
No, it's trying to open.
Yeah.
There we go.
Perfect. So this brings up the explanation of all the different blocks that can be used with the sensor in Scratch. Also, if you are here in this Scratch wiki, this is an awesome, awesome tool if you just want to do any Scratch programs as well. It goes through and explains what each and every single block is. For some reason, my internet is really slow. Okay, well.
What are you on? What?
Chrome, but I think I'm on PAL.
You're on PAL?
Yeah.
Well, that should be good then, but yeah, I'm on PAL too, and it seems to be going fine.
Okay.
You just give it a second. We're not in a hurry. You guys have never had internet go slow, have you?
Right. So within here, then you can just kind of play around and see, like I said, you can start to see all the different blocks and what those blocks, yeah, like, all the different blocks and then what each of one of those blocks do. I'm going to go back to, and then the sensor page, that's just a link to the Vernier site that talks about the actual sensor. The Scratch link is just to Scratch. And then this one is kind of cool. I'm going to open it in a new tab. So if you do really enjoy the Scratch coding and you do have these sensors, there are a lot of great example projects here by Vernier that uses both the Scratch coding and the sensor. So, and you can see right here's where I got my idea from. We don't always have to reinvent the wheel. And then as you are going through this lesson plan, I went ahead and created all of these links go to different Google Docs. So the pre-activity discussion is just like how you can introduce. There's a fly.
A fly right in front of you.
I wonder if can I get rid of that? Oh, I can. That go? Yeah. So when you click on it, it'll ask you to make a copy. Just that way we're not accidentally all editing the main one. So as you go through here, it gives you the purpose of
Keep going.
the activity.
Keep going.
Sorry if you hear all that banging. See, it's like teaching middle schoolers, always interrupting, right? So as you go down through here, it's just different like bullet points to think about as you are introducing this project to your students. And that's really it. Just easy, simple, but it's already made for you. So that way you're not having to Google and come up with all of your own pre-activity discussions. And then obviously you guys know to monitor progress, frequent check-ins. If you click here, this is an exit. I created all sorts of exit tickets for you based on, I thought I took out the days. Don't worry about the days, just look at the titles. This will it's not necessarily associated with the different days. Obviously, this is 9 days and I only have 5 days, but I've created exit ticket questions for you to use as well. And then one of my favorite pieces, at least that I use in the classroom very frequently with most of my students, especially in middle school, was the student reflection. And it just, as you finish up the project, like, what was one challenge you faced? How did you overcome it? Why, what did you actually learn? Explain what you did the scratch blocks to simulate the slowing down or speeding up of the lunar lander. So it's just, I just appreciate always having reflection from my students. So that way I knew that they were getting more out of it than just putting stuff on a piece of paper and moving on. Also, vocabulary. I know I was going to create a Quizlet, but everybody does their vocabulary different. Again, if you click on the link for vocabulary, you'll have to make a copy, but it's all the vocabulary and context for this lesson plan, because obviously, like, you hear Sprite and you could think of the soda, or you hear stage and you think of people singing and dancing. So it does, one thing I appreciate about this is that it does give the context along with the definition that relates to just this project. So then moving on, our daily activities. First, day one, you can see this is where we're going to be introducing the lunar lander project. You can make your introduction however you want to. You're more than welcome to use the pre-activity lessons that I put on here, or you don't have to. So I went through to look for some examples of lunar lander games, and A, they were either really loud, or B, they were super difficult for me to figure out. So I scratched that part of this presentation. But feel free to go ahead and download from the Vernier website the actual copy of their game. They do a really good job, and then it helps you kind of understand maybe even a different perspective from my perspective of how to create the lunar lander game. There is a teacher version in there that's already done for you, so you don't have to recreate the wheel, which is really nice. And then, for day one, then you can start to give a brief tutorial on Scratch, how to get signed into Scratch, and then kind of what a sprite is, how to start moving your sprite. So right now, what I would like you to do is go ahead and go to the Scratch page, the Scratch MIT.
Is that second link?
No, that's for the that's the actual project. It's just scratch.mit.edu. And the great thing about Scratch is you can log in as a teacher. You can start to sign up as a teacher account, or today, if you just want to sign up for a regular account, you can ask for verification for your account to be moved over to the teacher account, which is awesome. And then you can set up classes as the educator. You can add students yourself, or you can send a sign up link, and then you can create through the sign up link. It's kind of nice because then all of your students will have the exact same password, because we all know how kids are with passwords and that fun stuff. Then they're able to turn in their projects to you through this, and then you'll be able to grade it and see everybody's projects as well.
So do that one more time. Go back out so that.
Okay. So if you're in Scratch, sorry, I have a lot of oh. Okay, I can hide a window. There we go. So as you're in Scratch, today, well, here, I'll just sign out. That might be easier. So you can join Scratch here. You can for today's purpose, you can feel free to join it as just a person, or you can, if you just Google Scratch Educator account, you can request a teacher account, and then you start in with creating your own username and password. And then in the next step, it'll ask you for your email address. And then in the next step, it asks you for your phone number in case they need to call you. But when I signed up, they saw that I was a .edu, so they didn't even question it. And I know when I was teaching with my .in, .k12.in.us, they didn't question it either, so I didn't have to do much verification. It's pretty simple. So you can do it either way today. I can put this in. So I'll give you guys a few minutes to get signed in or signed up for Scratch, and then we can go from there.
I had to run upstairs to tell the guy to stop banging on the thing, and he had his headphones in. I scared him.
It was so loud.
Oh, it was loud, and he was like, "Oh, I'm so sorry. I'm so sorry." I'm like, "Well, you can start back up at 3."
Right? And then the lovely, like,
Yeah,
burnt
burning smell. He goes, "Can I grind?" And I went, "No, don't grind either. Don't do that."
No. That's funny. I don't even know where all of my windows went. Oh, okay.
If anybody's having trouble, let us know. Getting logged in.
I wish I could move this WebEx thing from the right above where all my tabs are.
You see what they're seeing.
I know. They don't see what I.
Continue. Okay, if anybody's not logged in, let us know. We're gonna go ahead and keep going.
That's
Okay.
fine.
Yep,
Perfect.
not a problem.
So as you're in Scratch, there's a few different places that you can go. Like I said, you can go to the My Classes. You can set up, obviously you'll add a new class, name it whatever you want to. I'll just do test 2, add class. And then you can start writing in here about everything that you want the students to know. Add your students. Like I said, you can add them one at a time, or you can send them a sign up link. The nice thing is that the sign up link, when you send it, it automatically creates them a password. So that way you're not having to guess everybody's password. And then you can, as you start creating activities, you can load in all of the activities. It's pretty simple. So right now, what I want you to do, if you're in here, is I want you to go ahead and click on create. And this is kind of what you'll be doing with your students the first day, is just getting them used to the environment. So I'm going to close the chat on my Windows so I can actually.
Yeah, that's fine.
Okay.
I got it.
Perfect. So right now you're in the coding environment, and you can see our little cat over here. That is what they call a sprite. He is the character that you will be programming to do. If you click on the little cat with the plus beside it icon down here where it says choose a sprite, you can choose from their sprites. The students can create their own, or you can create your own. You can make it a surprise, or you're even able to upload. So if you download a PNG or JPEG, from the internet, or you have Yes.
Why do they call them sprites?
I don't know how, I don't know that.
Okay,
I don't
I just
know.
was curious why they called it Sprite.
Yeah, I don't
All
know.
right, someone named it Sprite. Got it.
Yeah. I
Hmm.
when my kids were first talking about sprites and scratch, and
Yeah.
I'm thinking, I'm like, what are you talking about? And
Well-
they're finally like, Mrs. Brewer, it's coding, like,
Oh,
so. Because I'm like, no, you can't bring soda into my class.
right. That's what
like,
yeah, that's, I mean, all right.
Yeah. So you're able to choose anything that you want. If you hold your mouse over it, you can see the different animations that it's able to complete. And I'll go over that in a second. For this one, I'm going to choose Dot because he goes along with our universe exploration theme and he's cute. So I'm going to hover over the cat sprite and I'm going to go ahead and delete him. And then we have Dot here. And if you go into the costumes tab under here, this is the programmed motions that Dot does. So you can see that Dot can look like he is walking, or she, or he can even turn your back. So there's the different costumes that Dot can do. So, let's put Dot back in. So over here on then the left hand side under these, and you can add sounds too. Fair warning, it can get really loud and really hectic. The more sounds you guys understand. The more sounds involved, the louder your classroom gets. So you can choose to say mute it, no sounds, however you want to handle that. But there are sounds associated as well. Oh, I'm muted, so you can't hear it. But you can also choose sounds here, and there is a whole plethora. And if you just hold your mouse over the play button, it will play all the different sounds for you. Okay, so we're back in our code. These are the blocks over here. And I can move this motion block over where it says move 10 steps. And I can hit the green thing, but Dot's not going to do anything because Dot has to be triggered by an event hat block. So we can either do it when the green flag is clicked. So if I pull this over and I attach that block to it, as soon as I hit that green flag, Dot is going to move 10 steps. And you're probably like, well, he didn't walk. You're right. He didn't walk. He only moved 10 positions on the x-axis. That's all that means. So you have to start moving him with, so let's say if I want him to move 100 steps and I click it, see he moves much further. Which brings me to my next point. This book, I can't see myself. So
Right there.
I'm gonna, this book right here.
Unshare your screen for a second.
Oh.
And then it'll be big.
Oh.
So just go to the bottom and unshare your screen. There. Now you can show.
Perfect. Okay. So this book right here, the Everything You Need to Ace Computer Science and Coding in one big fat notebook, is probably one of the best resources that I can tell you to purchase or.
We'll give some information about this towards the end.
Yeah. We'll give more information about this towards the end. But this book right here is awesome. They have it for all different subjects. I highly recommend this. I even use the green, I can't move my finger in the right direction, the green one for my, when I was teaching 6th and 7th grade, I use these all the time.
When you were teaching science.
Yeah, when I was teaching science. And then I also use this when I was teaching computer science. So within this book, it's like a doodle notes version of everything that you teach. And then at the end of each of the little chapters is a check your knowledge. So it asks questions about what they just read, and then in this book, it actually gives the answers, but if you scan and upload it,
Yeah.
you can, it works awesome. So anyway, back to what I was saying. This book is awesome. There is an entire unit on programming with Scratch. And real quick, let me get to the page. It talks about movement, and then it also discusses you have to think of it as a coordinate plane. So as you have him move, your sprite move, you have to think of it as it's moving, you know, in the x-axis and y-axis direction. Okay. So with that being said, back to,
Which is awesome for graphing skills, right? I
Yeah.
mean, what a great opportunity to, that's, I never thought about it that way when you just showed that.
yeah. And if you know math teachers that need some enrichment also, coding is perfect for math teachers. So back to so let's say, so we understand that we've moved Dot now 100 steps, even though it's not really 100 steps because it's not, he doesn't show him walking. But you've moved him 100 steps along the x-axis.
Just a second ago, you just grabbed him and moved him?
Yeah.
Okay.
Yep. Sorry, you can move him wherever because sometimes he'll start to get off the screen and you're like, wait, come back. And so, yeah. Or whenever you hit the stop button, it should move him back to default. So different ways you can do that. When you bring in the when space key pressed, you can see that there's a drop down here, and this is any letter or number on the keyboard, and as well as your up arrows, or you can even do any key. So anytime I hit a key, see Dot moves.
And every time you hit the key, he moves 10 or 100?
100, yep. And you can move, we'll change it back to 25. So that way it actually looks like he's moving. But see, now that I hit the green arrow, he doesn't go anywhere. But as soon as I move a key, he starts to move. So now if you want to add in him looking like he's walking, you bring in the looks. There we go. The looks. And you switch his costume. So if you want him to move 25 steps, and then we want to move him to Dot B, and then we can see what that looks like. So see, it looks like he's actually taking a step. And then we move 10 more steps. And back to looks. And we switch him back to C. But see, it's hard to see because we need to add in a pause in between. So it's just, this is where, you know, you can give students code ahead of time. You can do some explanation. There's some really great tutorials. If you click on tutorials, you know, getting started, it explains the sprites. However you feel comfortable teaching this, go with what you feel is necessary. You can walk them through that. You can assign it.
And Jessica and I were talking about this, and I taught middle school science for quite a few years. I never gave out equipment for the first time and expected a kid to do a lab with it. I always wanted to have it where they had some playtime with it.
Right.
That way when we wanted to actually do the lab, they already had, kind of the play is out. so that now they're like focused on trying to achieve the task that the lab is trying to get them to do. And I don't care if it was a graduated cylinder. And I'm like, okay, they need to figure out how to just measure different water. I mean, and just and
Yeah.
understand where the meniscus is and all that stuff. That way, when they're doing the lab, I'm not having to explain to everybody how to use the graduated cylinder.
Right.
So I've seen teachers do it where they have punch cards where the kids can complete a task and then they get their card punched that they are certified in that piece of equipment.
Oh, yeah.
You see what I mean? So what a great opportunity for kids with this to be, your punch card could be 5 things that you want them to be able to do with Scratch. Go.
Oh,
And then when they get to I want you to make your sprite go up, down, do this, do that, do
Yeah.
that. When they do that, then they get their card punched. When they have all their card punched, then they are certified
yeah.
to be able to use Scratch.
Oh, that's awesome. I love that. Yeah. So this is just day one, just getting them in there, getting them used to, being able to choose their own sprite, uploading a sprite if they want to, moving their sprite, understanding, the different events, what happens when if the loudness gets over a certain decibel level, this is going to happen. When I hit this, when you actually click on the sprite, and then also there's all these different backdrops that you can add in as well. So there's a whole opportunity for a lot of play here for the kids, which, yeah, like Bill was saying, obviously they're going to play with it the more, because they think of it like, oh, this is a game, this is fun,
Yep.
and I'm going to be distracted until I, get settled into the understanding a little bit more than what Mrs. Brewer is telling me.
Right.
Yeah. So that's just day one, just getting into Sprite, all that fun stuff, or getting into Scratch. So then day two, this is where you're going to learn more of the basic, or teach more of the basic programming constructs. And that is where this awesome book comes into play. Like I was saying, you can teach loops, you can teach conditionals and different variables in Scratch. And like I said, there is a chapter for every single one of those in there. So even if today, if this is above your head, or or you're just like, I'm too overwhelmed to understand it, I completely get that. As a teacher, I know that a lot of things are thrown at you guys, and this is just another tool for your toolbox. That was one of the best things I think I had a veteran teacher tell me. I was at a professional development and I loved everything they were saying it, but I'm like, I don't know how to use this in my classroom. And they said, you don't know how to use it in your classroom right now. And then, so I thought that was really great. It was just a tool for my toolbox. So this is just another tool for your toolbox. So anyway, so your hands-on activity for today then will be creating a script to move your sprite up and down using keyboard inputs. And then I would even take it one step further and add in a loop and a variable to this. So when you're in Scratch, so if you're back in Scratch and you're in the control, you can have him wait. Oh, that's what I was working on. So if you have him wait between walking these different steps, then it will actually, oh, I forgot I have on keyboard. I'm going to change that back. And the best thing is like, you can drag and drop, and then if you don't want a block on there, you can just pull it over here and release it and it goes away. So your screen doesn't get too busy. So I'm going to pull a dot back. See, and then it pauses between, and obviously you can play around with that number. And then you can, obviously, if you want him to keep walking and actually taking more steps, then you can bring in this loop block, right? So we know that we want him to repeat this or loop for 10 times. So we pull our whole block in. So depending on which block you grab, everything below it will go. So I'm going to grab all of my blocks and I'm gonna just move them into my repeat block. And then everything has to be under an event hat. And so then when I click my green flag, hopefully dot moves 10 times. Well, I'll just do it 5. Well, we'll do it 10. So he looks kind of funny still, right? So it looks like we need to add in another weight before he takes his next step. So let's add in another weight. And if you can also double click, right click on the block and duplicate it, and it'll duplicate everything below if you want. Just to understand, or, well, anyway, I'll stop there for right now. So hopefully, so see, he looks a little better as he's walking across our screen.
That looked pretty good.
Yeah. So obviously you can repeat that more times, less times, however many times you want it to. Or if you really want to mess with them, bring in your forever, your forever loop, and then he'll just keep going. I've never done this before, so we'll see if we lose.
Okay, so you can move them outside of that box. Like you can move them anywhere on the screen at all.
He'll pop back into his little.
Oh, he stays inside the box.
Yeah.
Okay. Because that's the coordinates, the XY
Yeah.
axis coordinates. Okay.
And you can make this thing bigger too.
He gone. Oh, he's not gone.
He's not gone. He's not. So then you'll obviously have to hit the stop, and then you can grab him
Maybe.
and bring him back. Call him back. Doc, come back. So yeah, there's your 2 different like looping style blocks. You can do a repeat until something happens. That's a little more advanced. I'm not going to go over that right now. But yeah. So I'm going to stop there. Are there any questions on the loop, on the event, or how to, just simply click blocks together to get your little sprite to move?
And you guys can either unmute yourself and ask a question, or if you want to type it in the chat, either way is fine.
Okay.
Okay.
Perfect. So that's kind of day 2. Just keep it real simple still. Again, just adding in, like Bill said, maybe even now today you've added more things for their punch card that they have to do to become the experts. That's up to you. So day 3 is the fun day, in my opinion, and I'm sure it'd be more fun for you guys too. That's where you're actually going to be bringing in your vernier sensor. So this is the Go Direct force and acceleration sensors. They are
About 130, 120, $125.
Yeah, but they do I mean, there's all sorts of obviously experiments you can do with your physical science standards with this. I just like it because it's a 2-for-1 essentially. You can do coding and you can do your physical stuff. So I have a hands-on activity already mapped out for day 3. It's just to essentially reinforce what you've already taught, getting them used to, again, reusing the sensor if they've already used it, and just kind of maybe a break from coding, because we all know that computer science can be overwhelming.
When you do that and make a copy, and we're not trying to insult anybody's intelligence, but then that actually makes a copy that you have permanently in your Google Drive. So and then you can modify that any way you want after you have it.
Yep, perfect. And I need to take iPad. Well, yeah, I need to take iPad off of there now. Anyway, so this is just a quick activity. There's two parts to exploring the force side of things and a part two to exploring the acceleration sensor. I'm not going to get super deep in it today, obviously, because you guys are the science teachers and I'm the coder, and I'm going to focus more on coding than actually using the sensor. But I'm just going to show you real quick how to kind of connect it to your computer, what kind of stuff you'll need as you do connect it to your computer, and how it hooks to Scratch. So let's hit the power button and you can see, well, I guess I could just do it on mine, huh?
Yeah, either way.
It'll flash the red under Bluetooth until you're able to connect it. And when you're in a, so graphical analysis is a download from Vernier. So when you get these sensors, Vernier will explain all of this to you. So you'll click on sensor data collection and you see right away it pops up. And as soon as I click it, my sensor starts turning or flashing green. And then you are able to choose through here all the different, obviously, sensor types and how it graphs. For the force side, what I would do is, so if you go back to the activity, it's telling kids to understand what happens when you push and pull. So in Scratch, it'll give you the option when you're connected, when sensor is pushed and when sensor is pulled. That's why I have the kids doing that, so that way they can actually see it on the graph, like what happens, when things are pushed and pulled, right? You can see that the force goes either negative or force goes positive, depending on if I push or pull. Perfect. Then, if we go back in, this is where I learned at least, things got kind of tricky on the Scratch side, is when you start looking at the tilt. So activity 2 is where I would really have you kind of spend some time and let the kids really understand what's happening when they're tilting these sensors, because in the code, and I'll explain that here in a little bit, but I just want you to see as well, when we're graphing this, so I have the sensor laid flat. Can you?
Yep, I can.
Or there we go. Okay, so I have my sensor laid flat, maybe, wait.
Hang on. I can bring it up.
I'll move that over. Oh, perfect. Okay. So I have my sensor laid flat, as you can see. I'm gonna click.
Can you guys see the sensor? I don't want to,
Oh, that's
or do we need to stop? Yes, okay. All right, keep
okay,
going.
good.
All right, thanks.
Great. So I have it laying flat because when you, well, you'll see. So I'm gonna click here so it graphs.
And all you did was click on that and then you could turn on and off.
Yeah, you can turn on and off all the. So as I tilt it forward, you can see that the y-axis is moving, but there's also movement on the x and z axis, which can trigger the event to happen in Scratch. So that's why I think it's important for you to have your kids play around with this. See, like it's still laying flat, so you can see that the z-axis is moving, even though all I did was simply move it. but that's the best one. Yeah.
So all you're doing is rotating it.
All I'm doing is rotating, and it's moving the Z.
And the X and the, okay. That makes sense.
Right. But then, as you tilt up and down, obviously it's just moving your Y. And then and then I think it's this way that moves the X the most. So this is why I'm saying, like, let your kids play around with this so that way they understand what all the tilt means. Because when you are in, so I have to disconnect. So I'll go ahead and make the connection for you now. I have Scratch link running. Let me go into Scratch. And I'll go back through this in a second. But I just want you to see when you bring this in, it says face up and face down, but then also there's a when tilted, front and back. That's where it gets kind of iffy, and I really want you guys to let your students play to figure out what the tilts kind of mean. Does that make sense?
Yeah.
Okay.
I think it'll make more sense when we start using it too.
Right. Okay. Any questions so far?
What was the name of the program you used from Veneer?
Oh, graphical analysis. It's the free one.
Yeah.
Yep. And you can do the collection for longer. I just have it set for 5 seconds right now.
And so then when you go back to that, so when you're in there,
Oh,
that's all right. So when you're in there, you first turn your sensor on,
yep.
and I know yours is already blinking green, but because
Yeah.
we've already, but you first turn it on, and then you hit
The sensor data collection. And then I'll do. Oh, it's because my Scratch. Hang on.
the Scratch connected to it. So that's good to know. It can't be connected to both.
It can't, yeah.
Right there, that's a good thing to know, because if the kid's connected to one and they can't get it, that's why.
Oh, yeah. Hey, it can only be connected to one. Thank
Yeah,
you. Yeah,
right.
no, that's
No,
perfect. So now see it shows up here. And if you're in there and like the kids are like, I don't know which sensor to connect to, this is another good point. On the sensor, it has the number that should match up with the Bluetooth number on your device.
Because, and I know this because I work a lot with this. They need to know that, because if you have 10 groups trying to connect, they're going to show, if they're close enough to it, that you don't want them connecting to their neighbors. So make sure that they look at the number on there.
Yeah. So then you just,
So they asked a good question. How many students would you recommend in a group for this? Go ahead. I'll let you say it first, and then I'll say a number.
in my opinion, for coding, no more than 2.
Okay. I'm a big fan of groups of 2, because I think once you get to 3, 2 of them are always going to mess around.
Yeah.
So if you can keep it groups of 2, great. But I also understand constraints of availability. So you may need to think about whether or not you do this as a station then, and so that you don't have to have, 15 of these, so that every groups of 2 can have it, or however many students you have. But I think if you can do this in groups of 2, I think you're better off.
Yeah. For coding, at least, they suggest a max of 2, just because then you have they call them drivers and coders. So you have one person like writing down and thinking about the algorithm, and then you have the actual person like coding what the driver is saying. So you have your driver and your programmer, and then you know, you as a teacher, you can decide if you want to have them switch that role every 15 minutes or every other activity. So that way, but really, no more than two, because then you start to like, at least in my experience, you start to have too many chiefs and not enough Indians to, and then the discussion goes, you know, way beyond where it needs to go. So for simplicity, I would say two. And I can put a link to a good resource that discusses that as well up on just the general outreach page.
Okay.
So,
Yep, we can do that.
yes, Vernier does work with Chromebooks.
Yep. So, and we want to make sure we're clear on this. Veneer will work with Chromebooks, it'll work with iPads, work with all this, but Scratch will not work with the iPads when you are using
The sensor.
the sensor.
Yeah.
It will work with Scratch,
Yes,
but not Scratch with the sensor.
correct. And these work with this iPads, right?
Yes, Veneer sensors will work with iPads.
But for some reason, Scratch link, so that link that goes between the sensor and the actual coding program does not work on an iPad.
So a second ago, when Jessica went to Scratch and then found the sensor, if you were on an iPad, that would not work.
Correct.
Okay.
Perfect. So so you go back into Connect. Okay, I'm green. And then you can change the different sensor channels here. I mean, one of my favorite activities always as a science teacher was to do the cars and the ramps and to do acceleration. And you can do that with this. You can, so it's,
You can do, with this, you can also do, because it has the force, you can do it where you pull blocks of wood across different surfaces to look at friction.
yeah,
So, I mean, there's there's tons of labs with this.
right. And it comes with a longer rod and a different screw cap on the top. So
Yeah.
It's a great tool. I just love that you can even then do coding with it.
I wish I use sensors when I taught, and I wish I would have had one with coding. So this is cool.
So there's kind of how that, and like I said, Vernier graphical analysis is the free version through Vernier. I'm gonna go ahead and disconnect, so that way when I'm ready to do the Scratch link, I'm good to go. Are there any questions over the Vernier sensor before we kind of move on to the next one? Okay, perfect.
Once again, if you guys have questions, type them in the chat, or honestly, there isn't that many of you in here. So if you want to unmute yourself, feel free to unmute yourself.
Yeah.
And ask a question. We'll stop.
Great. So yeah, so that's day 3. Just getting used to and understanding really how the sensor works. And then day 4 is where all of the fun kind of starts to happen, in my opinion. You have your your block coding understanding in Scratch. You have your understanding of the sensor, and then this is where they both come together and really integrate, and you can make all sorts of fun different games with it. So if you click on the, oh dang it, I did the wrong thing again. So this is where obviously you're gonna, I'm probably gonna go through this one pretty slow, just so that way you guys can understand it and ask more questions about how to actually connect the sensor to Scratch and stuff like that. So this is where you're going back into Scratch, and you are having the kids think about how their sprite is moving in Scratch and whatnot, and then really thinking about how this sensor can interact. So like if you want maybe I jumped ahead. Should I go back and like create the game and then we can enter?
Yeah, let's do that.
Okay.
Yeah,
Yeah, let's hold off on day 4 for a little bit.
yeah,
Okay. Sorry.
that's okay. No, I think that was a good idea.
Yeah, like I'm like, wait a minute, because we don't even have a game yet, so they don't even know how it.
Yeah.
Okay. So this is where that second link comes in handy. I'm going to.
Can we bring it back up again?
Yeah, that'd be great.
Okay,
Nope, not that one.
not that one.
That one.
That one.
Yes. Perfect. So the other great thing too is as you create stuff in Scratch, it saves for you, and then all you have to do is click see inside to go back into it. So I'm going to see that if you guys click on that link, it should bring up the background and sprites blank project. And all you have to do is hit see inside on it. And it should bring up a project that looks like this. Does everybody see this? Because this is kind of where we get into the meat of how to move our.
Okay, thanks, Chris.
Awesome. Yes.
And Jamie. Awesome.
Yay. Okay. So, you are more than welcome to use this already. I didn't think about that. I can add this link into the lesson plan as well. To already use the background there and this lunar lander and your target sprites, that you will not offend me at all. Like I said before, there's no point in reinventing the wheel if you don't have to. All I did was download this cute little sprite. So if I go into costumes, there he is. Downloaded that from the internet as a PNG, pulled him in here. Well, I guess I can show you real quick how to even do it. So again, you're gonna go to upload a sprite. I think he's on my desktop. Isn't it? Nope. That's the one I did not like. This one. Right here he is. And it's as simple as that. But see how big he is? It's massive. Like he's bigger than my target and my moon. So I go into costumes and I convert it to a vector, and now I have this square around it, and you can resize it. So this brings into play another thing, like depending on how big or little your students make that sprite can make the game easier or smaller, right? Because
Easier or harder?
oh yeah, easier or harder,
Yeah.
sorry. Easier or harder, because obviously if your lander is huge, it's gonna hit the target pretty simple. So I am, I don't know a different word. I'm anal about things being centered. So I'm just going to go ahead and center him in the middle of my screen here. And so now you can see it's a pretty decent size compared to my target. And I'm going to go back into my code.
And you didn't have to save anything when you did that. You just move it and let it sit.
Yep.
Okay.
Move it and let it sit. And then now, I can drag it
Inside there.
inside here anywhere I want. I can drag my target anywhere inside here that I want as well. Okay. Okay. So now we have to think about, and kind of this is where that day 4 comes in, is thinking about, obviously, it depends on, and this is another thing too, if you want to just make this a fun few day thing that the kids can use a sensor with, or even just to code with, you can make it that. Or you can go into, gravity of the moon versus the lunar lander, like how fast you want that thing to fall, however in depth you want to go. But
So when you say that, basically it comes down to how many constraints do you want the kids to have?
Mhm.
Like it has to fall at a rate of this, or when it finally lands the last 5 feet, it needs to move really slow.
Right.
Something along those lines. That's what so you can decide, or I need it to go to a highest point before it starts to fall.
Yeah.
Whatever constraints you want to give.
Yep.
Okay.
Perfect. So so obviously we want to see how my target, code is currently active, and you can see up here in the screen too, right? So if anything that I move over right now will be coded on the target, not on the sprite. So that is important to understand, that you are not coding, that where you are actively coding. Because there's not a lot much more frustrating than having awesome code and then realizing that you did it on the wrong thing, which brings up another great point, is always, always, always check. Like as soon as you bring in a block, I always hit play and check. Like that's one of the best things that you can teach your students. And even that goes well beyond just block coding. Like as kids are learning programming and coding in different languages and everything, I put in print statement after print statement after print statement, because I want to make sure that I don't have in 50 lines of code and then all of a sudden I'm like, there was an error back in line 10 that I could have, saved
Stopped, yeah.
and done a print statement with. So now you can see I have my lunar lander active. So events, where I like to start at is understanding the arrow keys. So I'm going to bring in 2 blocks, and I'm going to do one with up arrow and one with down arrow. And if you guys want to follow along, that would be awesome, because then you're actually getting hands-on experience with this. And then also if you have questions that come up as you are even coding it, and we're right here, we can definitely support that as we go. So feel free to interrupt, feel free to send something in the chat if you're completely lost. That helps me out, help you guys out. So right now I have an up arrow key pressed and a down arrow key pressed. So I'm telling my lunar lander right now that when I press the up arrow, I want it to do something. So I go into my motion block and I want it to move 10 steps. So then when I hit my up arrow, what is it doing? It's moving. Why is it doing that? Does everybody know why? It's moving on the x-axis, not on the y.
Because you just had it with the up arrow. You're just telling the up arrow to make it move.
Yep, I'm just telling it to move, not giving it a direction. So this is where we look at our different blocks and we're able to see the change y. And we want it to change by 10. So see?
Do it again. Oh, okay. So now we're going by Y.
Yep. So I can make it more dramatic, right? Because doesn't that make sense? You hit an up arrow, you think it's going to go up. So let's say we can make it more dramatic and make it go up by 50. See? So now what makes logical sense for the down arrow is for that lunar lander to go down. So you can bring in that change y. And this time you can have it by negative 50. Because, right, that x-axis and the y-axis, see now it's moving down the y-axis by 50. Depending on which key I press. Good?
That's cool. Yep. I'm
Okay.
good.
Okay, perfect. So then, let's go back to our events. And let's think about, well, he only moves up and down right now. What if I need to, what if my target is clear over here and my lunar lander is clear over here? How do I get him over here? Well, now we have to think about motion, right? In which direction we want him to go. So I'm going to bring in 2 more event blocks. And I'm going to do right arrow and left arrow, although I should move that backwards because okay. And you can turn him. So now when I hit my left arrow, see it tilts him. And you can even have him move. Did I do that? Oh, I hit the wrong key. Sorry. See how he starts to move even as you turn him? So now I can.
So, okay, but hold on, but what are you hitting when you're doing that? Are you still just hitting the left arrow?
Yep. So when I hit left arrow, see how he's just barely moving along the X and Y and turning at the same time?
Yeah, okay.
So now if I went, obviously I don't have my right arrow. I just have my right arrow programmed to rotate and not to move. So see. So I'll give you a few seconds to kind of play, or a minute or so to. So that original blue box, it doesn't have. Oh, great point. Thank you, Tanya. Yes. So this thing here, he does not matter unless he is given in that event hat block. It won't do anything. I can pull in
Tons of stuff.
anything I want it, or anything I want, like looks, this, like it doesn't matter what I do.
Because it's not connected to an event block.
Yep. Now, as soon as I put an event on there, right?
So no matter what you hit now, because you said any,
Yep.
it's gonna say that.
Yep.
Okay.
Great question. See, now I hit my C and he shows up. I hit a different key and it goes away.
That's pretty cool.
Yeah.
Okay.
That's what I was saying. Like, and then the best part about this is you can just get it. You can just drag it over here and they disappear, or you can just hit delete when you're over the top of it.
So, and I know everyone's a little different, but as a teacher, when you were doing this, would you tell the kids to kind of try to keep it somewhat clean over there so they're not somewhat connecting something that wasn't meant to be connected?
That was always my suggestion.
But different kids are going to do different things.
Exactly.
My roommate in college was an aeronautical engineer, and he had the messiest room out of any person I ever lived with.
Yeah.
But he was so organized in his mind with what was what.
Yeah.
So I could see him doing that, leaving stuff everywhere.
Yeah. So I used microbits and Microsoft Make Code. It's another block programming. And some of those kids, they would bring up their stuff to try and have me help them, and I
drive you nuts.
I couldn't even, like, someone would be like, I can't even deal with this, and I would just go in and start deleting stuff, and they're like, why are you deleting that? Like, because you don't even need it.
Yeah.
But that's a great question. Thank you for bringing that up. So it's just all on how you think about, and honestly, I would take out the change Y on these because really you just want your up and down arrows to, but you do want him to move along the X axis as you start to rotate him. But yeah. So are there any questions about, just getting him or your lander to move up and down and around?
I mean, I have a question, but I'm sure you're going to come to it. So, Because I mean, you're showing us how to do this in block coding.
Right,
This has nothing to do yet with the sensor.
correct.
Okay. This is just learning how to
Yeah, just,
move this thing.
yeah, just to understand the basics of the game. So right now, we're just,
The game is to get that lunar landing, is that what it is? To land on the circle.
yeah, so Kathleen just added the sound. Yes, and imagine that times 25 or 30, and some of the kids think it's hilarious to have their iPads at max volume and
But I still have a daughter that's in middle school. She'll be an 8th grader. They all had to have headphones.
oh,
So
so earplugged it.
yeah, right. There you go. Right. And yeah, our school, they had to have headphones, and I'm sure it was because teachers are like, I am not listening to everybody. Yeah, right. That's funny.
Yes, that's awesome. So yeah, so right now we aren't even doing anything with the sensor yet. I kind of guess I jumped ahead, with the sensor thing, but I'm just thinking about we just want to get the game understood.
And the game is to get the lunar to land on the circle.
Yep.
That's it.
Yep. And so, so let's think about then, okay, let's go back. So we automatically want this lunar lander to keep going down, right? Because gravity is constantly pulling the lander towards the moon. So let's say when we click our green flag, we automatically want that lunar lander to fall. So we're going to, so one thing I like to put into gameplay is this go to random position. And it will move your lunar lander all over the place. But obviously we don't want him to be too low because then that takes away from him being able to fall. So after we hit go to random position, we can set our Y to a certain number and think about, if 0 is right here in the middle, and I think it goes up to 200, I think is what the top, I think it's close to 200. So we want them to be towards the top. So let's just go to 150 and see what happens, right? So he's always going to be way up there at the top. We can go. Okay. Does that make sense, everybody? So right now, he's just jumping all over the place as soon as
He's jumping all over at 140.
yeah.
Okay.
Yep. And then after he's there, we want to think about how do we get him to keep falling, right? Because right now, if we just move him change Y by, negative 10, all it's going to do is move it randomly and then down 10. So it's not really doing anything. So we have to think about how do we keep getting that to fall, right? So we want to repeat changing Y by negative 10 until something happens, right?
Mhm.
But when do we want him to stop, right? We want him to stop when he hits the surface of the moon or crashes. So we bring in our variable. See, and this is kind of where it gets complicated. And why I kind of wanted to do this with you guys together, so that way we kind of understood it best. So we want it to repeat until it hits a certain Y axis, right? Obviously, he's gonna keep till I hit stop. It would have every time I pulled that back up, it would have kept dropping because I don't have anywhere for it to stop.
So can I ask a question?
Yeah.
if you move, like when you're moving that lunar lander,
Mm-hmm.
move it to the point where you want it to stop right now.
Probably right there,
Okay.
right?
And doesn't the coordinates show you that on the, sorry, did I jump ahead?
Gosh, no, I didn't even, I just always ignored that.
Because there's your coordinates.
Bill,
Well, I was watching you move it and it was moving as you were moving it. So,
of all the years that I've done this, I've just always ignored those. Okay, now my face is turning really red.
no, but
That's
yeah.
awesome. Thank you.
Okay, so this will be interesting. So I saw that. What were you going to do?
I was just gonna go to negative 150.
So do that. Let's see what
Okay,
happens.
so we want here's where we have to bring in, see how that is a hexagon?
Yeah, I can't. That's small for me. Okay.
And we want it to be equal. So we need,
Oh, so you're gonna drag that into there. That's
yep, I'm gonna drag that right into there. And then here, obviously, we need to figure out where the Y position comes in at, because we need it to repeat until Y position. But see how that's still a blank?
yeah.
And then if we went back here, see how Y was in color blue? So we know that we need to go back to our blue blocks. And we have our Y position here, which we don't want it to show. See how when I click on it, it shows the Y position up here as well? We don't want it to show there all the time, so we can just drag that Y position right into there. So let's just do this, hit our green and see what happens. See how it stops it at 50?
Oh yeah. Okay.
So then if we do it down to what was I going to do? Negative 140.
Yeah, you said
Or
one.
you can move it right down there and actually look at your Y value, which is 122. But hey, you know.
Yeah.
Thanks, Bill.
Well,
That's you learn something new
I
every day.
yeah,
Wow.
right.
So see, now it. What happened to my random? Oh, because I hit. There we go. So see, now it's just dropping randomly and it'll stop as soon as that lunar lander hits.
Right now, negative 140.
Yeah,
But if you type in negative 122,
right. Then it'll land up higher.
it should go right where the. Oh,
Oh, did I hit? Do I have something weird in there?
it went down to.
Oh, because I hit this, set Y to. No?
Oh, you know what though? That might be right. If you set it to 140 and then you're going down to you're going down negative 122. Move the lunar over to the thing again, to the.
Oh, well, hang.
Yeah,
Because it's going to keep going.
Yeah.
Yeah. So, wait. No, that shouldn't be. I don't know why it's doing that. Go back to 1. Oops. Oh, yeah. Because that should be a bigger number because
Yes.
the further negative you go.
Right.
No.
Well, if you're at 120, if you were at 140 and you go down to what's the difference between?
But it worked that time. See, look.
Oh, it did.
I don't know. Maybe it was just a
Okay.
random fluke in my.
Okay. Whatever.
Yeah.
It worked.
Yeah. Okay. So I'm going to slow it down though, because that goes way, way fast. So as you can have it like, I'll just show you this. So like as it's moving down, every second, then it moves. And then see, as I'm hitting my arrow keys, it's moving it. It's still affecting it because it's gonna keep going until it hits that Y axis at that certain point, no matter how many key presses I do.
Oh, okay.
Does that make sense?
So it's falling and then you're controlling it by doing the other
Mhm.
arrows.
Yeah. So there's two different ways that you can affect how fast or slow it falls. You can either change it Y by a large or smaller number, or you can have it wait so long between each time it falls. Okay?
Okay.
Okay.
Yep.
Okay, any questions so far? So now we have two things in play. We have the lunar lander is falling because we told that to change its Y position by -10 every second until it reaches that -120. And then we have the lunar lander is moving based on what keys we press, right? And we only have half an hour left and I have a lot of stuff to go through.
You're good.
Okay, are you
Okay.
sure?
Yep.
Okay,
Yeah.
all right. So are there any questions then before I move on to start moving the target? Okay,
All right.
perfect. So then obviously we want it to be more difficult to move our target as well. So like we want our target to move, we want our lunar lander to move, and then they have to figure out key presses and all that until that lunar lander hits the target. So we're gonna make sure we're on our target. We want it to start when the green flag starts as well, or is clicked as well. So we're gonna bring over that flag clicked. We also want it to go to a random position, but we want it to stay along this axis down here. So let's say we want our target to always fall to -1, or we always want it to stay at the 145 range. So we're going to set our Y. Oh my gosh, I just realized that. Look,
It gives it right away.
it gives it right away. I don't even have to change anything.
Wow, that's pretty cool.
Yeah. All right. Well, everybody gets to learn something new.
It's fun learning.
It is fun learning. And then, so basically what it's doing now is it's moving in random positions along as well. Okay, cool. Perfect. So let's go back to our sprite because we want it to be able, we want to know when we actually hit our target, right?
Yeah.
And we want it to tell us something, like
When
you
we-
did it,
Okay.
or
Or a sound.
or a sound, or you crashed, or something. So if it doesn't touch this target, let's say we want it to say crash, right? For 5 seconds. So now when I hit this, okay, we need to speed this bad up. Crash, right? We didn't make it. We didn't hit our target.
Now, how did it know it didn't hit the target?
Because I don't have an event on the target that says that it touched it.
Okay. Got
Great
it.
question.
Okay.
Yeah. Okay. And so then if it crashes, I'm going to make that lower actually. Let's do -1. Okay. So now we know that when we hit this, right? What in the world? Why is it doing that? Anyway, welcome to technology.
We'll go back to put it back at the 120.
I don't,
Went to 222.
but I also don't know why this is still highlighted. Anyway,
Okay.
we're just gonna keep moving on. So obviously, I don't understand.
Completely take the number out of there again, like completely just like, and then do it again. Okay, now put in negative 122. See if that does it.
Yes, see? Yes, perfect, Jamie. The kids will obviously figure it out because they, but for some reason, like this is still highlighted and I don't understand why. I guess I could hit save now and see, and then refresh and see what happens. Oh, it's on the target. I'm like,
Yeah.
where did it all go?
No, you didn't.
See, now let's see. Nope. It's still highlighted. Anyway, yep. The kids will figure it out or it'll write itself. Who knows?
Yeah, right.
Exactly. Yes. Okay. So we have it falling. We're able to control it. It'll say crash when it doesn't hit the target. So we want it to stop when it does hit the target and say you did it, right?
Mhm.
So we're going to bring in our wait until. So we want it to keep, we want this to be active, but we want it to not do anything. So it's going to be holding until that sprite touches our target, right? So we need to go back to our operators to see we have our little triangle here. Oh, but just kidding. We want to go to our sensing one because we want it to be, we want it to wait until it touches, and that should, the lunar lander, okay?
Oh, because that's the name that you had it
Yeah.
on the, okay, that's why it says that.
Yeah,
Okay.
that's why it's that big long thing, but it's the lunar lander clip art. So when the vector touches the target, when the lunar lander touches the target, then we want it to say, congratulations, right? We'll just say success.
I like success.
And then we want it to stop everything, right? Because we don't want it to say crash again. We don't want it to, activate anything else. We want it to completely stop. So we need to stop everything. And if you click on the stop all, it'll stop either the target script, it'll stop other scripts within this sprite, or you can just have it stop everything. So we want it to stop everything. So now, hopefully, we can get our sprite to behave. See, and it touched success, and it should have stopped everything. I don't know what, unless I put, do I need to put a stop all here? Maybe that's it. Oh my gosh, this is embarrassing.
The Y position equals, repeat until Y position equals negative 122.
Oh, I don't know. That really frustrates me. So anyway, let's go all the way to the end of our game and let's hook our sensor now because I don't understand what's happening. So we have it now where it's falling. We're able to control it with key presses, but let's say the kids want to control it with, it is highlighted because it is running until you hit the stop sign. Oh,
That he put that in there earlier
oh,
when you said it was highlighted.
oh, and then it stops highlighting. Oh, I don't know. Okay, anyway, let's move on to the sensor. I forget where I was going with this. Okay, so we want now we want to attach our sensor. Say our game's working, the kids have their games working, however they want to play around with it. And see, and that's the beautiful thing with coding too, is that literally every single student group could have a totally different version of this game, but it all accomplishes the same thing. Like it's just different ways to do it. And I guess that's what I enjoyed the most about coding, is just seeing all the different ways that kids came up with the same end result, but they were able to think about it. You know, they were able to pull in their reasoning and think about it totally different and still like, you know, make it work.
Yeah.
That's the freedom, I guess, the freedom and the confidence that you can build through coding. Okay, so we're going to hook our sensor to Scratch, and this is where, so we have our sensor, and you're going to turn it on, and it should be flashing red, and you're going to hit this blue or purple down here where it says add extension.
I didn't see where you were.
Oh, all the way at the left, down at the bottom.
Oh, there on the left. Okay.
Yeah.
Got it. Now I see her.
And there's all these different extensions you can add in. I know someone had said they do Lego, so you can even do Lego stuff with Scratch. And I didn't know you could do microbits, but that's cool. Okay, so sorry. So you have your Go Direct, and you're gonna click on this. And actually, hang on, I'm gonna make it break for a second. So if Scratch Link is not working or not turned on, it's going to say this. Make sure you have Scratch Link installed and running and check that Bluetooth is enabled. And so you're going to go back in. And this is as simple as just clicking Scratch Link and see it pops up here in the top of your screen. The same thing with Chromebooks. It pops up in that toolbox up there. And you're going to hit try again, and it found, and this is again the important same thing with graphical analysis, is you're going to look and make sure that your IDs match the device name, and you're going to click connect, and it's that simple. And so then see, it brings up all of these green blocks and the event hats. So I'm going to actually break this for a second so that way you can see what happens. So when you're shaking it, let's say you want to change your Y by 50. So see how I shook it and it moved my lunar lander up.
Okay.
Just by simply shaking
Just
it.
by shaking it.
Just by shaking it.
Hmm.
So then the different triggers here, that when it starts falling, if you're brave enough to let the kids drop your sensor and catch it, that's I wish you guys could all see Bill's face right now. If you are brave enough
My face just dropped. I was like,
Yeah,
thank you, Kathleen. No.
yeah, yeah, exactly.
Otter fox. Yeah,
They would be,
okay.
yeah. So anyway, you can do wind started falling, and I did try it at home. I dropped it and caught it, and it does work. And then where
Okay, hold on. But if I had, if they were connected to a spring
oh, I didn't
on
think
a,
about that.
on a ring stand,
Yeah,
that I knew it would be strong enough that it wouldn't go all the way down, I might,
yeah, yeah.
maybe,
There you
maybe.
go.
Okay, keep going.
Anyway, you can turn it face up. So, but you have to remember, you have to bring it back upright so it doesn't do it, like you can't just hold it and it keeps going. Like you have
You have to rotate it each time.
Yeah.
Okay.
And then the same thing with, well, come here, little buddy. There we go. And then the same thing with turn face down. So like the kids can think about that, like if you want it to slow down towards the, face or surface of the moon, like how you want it to turn, etc. Okay. So let's get rid of that one. And we can bring in pushed and pulled. So that's where, you're pushing it. So literally you're just pushing at the bottom and then move it back to pulled, and you're pulling it at the bottom.
Okay.
Making sense?
Uh-huh. It is to me.
Yeah. And then this is where I struggled to get wind tilted, because, well, you saw like how that in the verniers thing is when it's tilted. And so when you're tilted front, it's fine. But then when you try and do, like, if you want it to do the opposite when it's tilted back, so tilted front, but then see, as soon as you move it back, it's very
Yeah.
weird on how, like,
How far it goes before it finally goes
Yeah.
the other way.
and so that's where I struggled with the tilted front and back. And the same thing with left and right, like, so that's where, the kids can kind of go in and start playing around with it and figuring out what they want it to work for them.
I don't know what made me think of this. Remember the toy Bop It?
Yes, pull it, push it.
Yeah, that's what I'm thinking about right now.
Yeah.
And so I'm thinking, okay, so if I have them pull to go one way, but then I turn it to do another one.
Yeah.
Okay, keep going.
Okay. So for purposes of time, since I couldn't get my game to work, I'm going to use Vernier's version real quick so that way I can actually show you how the sensor actually works with a working game.
Okay.
And feel free, you can give the kids the Vernier game, obviously, so that in case they have issues too. To be able to do this. But see, they've added in where they have fuel and thrust, and all sorts of different components, scores. That's what I guess I love too, is like there's just so much you can do with it. You can make scores, you can make it, you run out of fuel, you can make it thrust.
Which, and I'm sure you guys have all thought about this. I mean, so this is great for differentiating instruction based off of the levels of the kids,
Yeah,
right? I mean, you could have one group where you're like, okay, you're going to do this, and other kids like, I just want it to fall and be there, and that's it.
right.
Okay.
Yep. So I'm going to take these event hats off. Actually, I'm going to put those back above. So we can think about, so when the down arrow is pressed, this is where I like to think about if we're pulling the sensor, it'll move it faster. So that's where I'm going to bring in when the sensor is pulled. And when the up arrow key is pressed, it's pushed. So right now, if I hit the green, if I pull it, it should have moved faster. Oh, it did. Look at I have it, hang on, I have it messed up here. Change thrust by, and then fuel. I made it easier as I was playing around. So see how it's moving faster? My thrust is actually like going down, so it's moving faster. So when I do this, if I see I'm pressing and see it's moving slower as it gets down towards. Okay. So that's all I'm saying. Like think about, and then let's say we want it to tilt to the right to move it instead of like the right arrow going. See how it starts to tilt it? But that's where this is where it got kind of complicated for me, is like understanding that you have to keep moving the sensor back and forth instead of just holding it. Cause see how I keep moving it and my sensor is still moving, or my lander is still moving.
Yeah.
So just different ways to think about how to incorporate coding into your classroom with some stuff you already have. Or if you don't have it, then yeah.
Yeah.
Then you can still do coding, and
You need to go back to the lesson plan to kind of.
yeah. So to wrap it up then, the day 4, the guiding activities, it's really, you can give them this, like down here is like the worksheet that I came up for the actual students, and thinking about, when a certain key is pressed, do you want to increase or decrease the speed of the lunar lander? Guiding questions about thinking about, if you hit the down arrow, does it make sense for the lunar lander to slow down, or does it make sense for the lunar lander to speed up? So just thinking about stuff like that. And then if you pull on the sensor, does it make more sense for the lunar lander to speed up? Like that's just what these different guiding questions are and challenges are within this worksheet for day 4. Is as they keep programming about it, or programming it, thinking about these different things that make more sense. And then obviously day 5 is how they can continue testing, they can continue refining, and then if you want them to present their game, how you want them to present their game, and then obviously that last reflection piece that I talked about earlier. So.
And you mentioned when you were talking about this, that presenting the game, it could be where everybody rotates and they have to play the game with someone else's rules based off of what they coded.
Right.
Right.
Yeah.
And I think that's kind of cool because they've learned how to do theirs, but now all of a sudden they have to do it with someone else's.
Well, and the perfect thing too is if you don't feel comfortable having kids rotate iPads, the best thing about Scratch is I was able to share out my game. And so you can have kids share out
their game to other people
and still use their same device.
Yeah, so that's cool.
Yeah. Because I mean, I knew I had some kids that there's no way I would let them use someone else's iPad.
Do you want to share with them the kind of the evaluation stuff you talked about?
Yeah. So that was this one, the student reflection, really thinking about the challenge. So obviously my challenge today was my stupid lunar lander kept going and going. I wasn't able to overcome it, but with some more time and whatnot, thinking about how that you overcome that, thinking about the design and the gameplay, and how that can come into play even with gravity. Like, so if you decide that you don't even want to do the moon, you give one group Jupiter, you give one group, and then how much faster things are going to go depending on gravity. Like, how deep do you want to go into your physical science standards for this? I guess it's another great piece. Yeah.
And I'm going to say this, and I'm sure the rest of you agree. I like it when things don't go quite right. And I mean,
Yeah.
and because really that shows the true, like, this is real. I mean, this is not like
Right.
it's, and it didn't make sense to me why that didn't work.
Right.
But I guarantee when we're done, you and I are going to sit here for a couple more minutes to figure out why it didn't work, because it's going to drive me nuts.
Right.
So, okay. Before I'm going to stop the recording here in a second. Before I do that, are there any questions that the teachers have? Don't leave yet. I've got some information to give you, but are there any questions that teachers have?
There we go. Now I can see you. I'm going to put my email in the chat or not, Gmail, in the chat as well.
Yes, it is recorded. So, and I'll show you where that'll be here in a second, where the recording will be. Do they have to save it?
Yes, so you do have to save it. That's a great question. Let me go back and share my screen. Perfect. So when you are in Scratch, then is this?
Yeah, that's the one we did.
Is that the one I was on?
Yep.
Was it? Because none of my code's there. Oh, here we go. It's right here. Then you can do.
Well, this is the one that you did through.
Yeah.
Okay.
So you can do file, save as a copy, save now, or save to your computer. It doesn't matter. Or as you're going, you can also hit save now here as well.
Okay.
Perfect. Great question.
Yeah, that's a good question.
Yeah.
Because when you did some stuff earlier, you didn't have to save it. When you were in the middle of moving things,
Right.
it just automatically kept it.
Yes.
But at the end, you need to do it. Okay.
Yep. I don't think you have to, but I think it's good practice to save it, to do the save now. Plus, when you try and leave too, it'll say, do you want to leave? It'll keep asking this. And if you do leave, it won't save your changes. And then you can hit save now.
Okay. Okay, that's good.
Yes, kids are used to Google saving. I agree with that.
Yeah. Yeah.
Well, I mean, let's verify. So that's.
Yep, it will need to be repeated to them.
Yep, it does not save unless you hit save now. So.
I've gotten the same with Google. I mean, I love that it saves it no matter what I do.
Yeah.
And then I do a document and I'm like, crap, I didn't save that. So. Okay. Any other questions? I'm gonna stop the recording, but then I want to share some other information with all of you.
Oh, I had a.
Okay, I'm gonna stop the recording.